Hello, all of you. I hope you are doing well. So, let's start with the VLSM, that is a variable length subnet mask. If you gone through the previous lectures, we have studied the subnetting, and in the last lecture, we have studied or we have discussed some part of VLSM. So, in this lecture, we are going to learn the things in details. So the VLSM is nothing but a variable length subnet mask. So it is must or it is a more useful than the normal subnetting. So how exactly more useful that we are going to learn in this lecture. So I will give you the very short topic, or we can short hint how it can be useful. Now you can see in the subnetting we are using 24 in the CIDR, that is in a classless routing. In that, what happens, suppose you are using the 24. So what is the meaning of that /24? So the last 8 bit are used as a host, and remaining 32 bits are used for the network ID, and the last 8 bit or last octet can be used for the that is nothing but the host IDs. Okay, so what is the meaning of that? So last 8 bit means 255 network addresses you can use in your network. But sometimes what happen, you have very short network, so you can using only a 10 PCs in that network, so you can require only 10 IP addresses. Now if you are going for that 8 octet, or you can going for that 8 bit host IDs, means 2 raised to 8, that is 256 IP addresses you can use for that short or very less IP addresses. Means you require only 10, but you are taking the network of 256 IP addresses. So that is not very handy, or you are almost wasting the 245 IP addresses. So this is not very useful. So for that purpose, we are going for the VLSM, that is a variable length subnet mask. So limitation of using only single subnet mask across a given network prefix, the network address, the number of bits in the mask was that an organization is locked into the fixed number of fixed size subnet, that I already explained you. In 1987, RFC 1009 specified how a subnetted network could use more than one subnet mask. So VLSM is equal to subnetting of subnet. I hope you understand, subnetting of subnet. If you are already subnetted, and again we are subnetting that subnetted. So I will explain you how exactly in the coming slides. If you know how to subnet, you can do the VLSM. So you know how to do the subnetting. If you have gone through the last lecture, so I hope you understand the subnetting. If you know the subnetting, then you understand the VLSM. So here I am taking one example, the VLSM example, that is 30 subnet /30. Suppose here is IP address 207.21.24.0/24. So it is one subnetted. Okay. Now if you it's subnetting in /27, means what, that is the last masking is what, 255.255.255.224. So if you know how that 224 comes, if you gone through the last lectures. Now I'm making here /27, means there are how many IP addresses in the last in each subnet, that is 24, sorry 30 IP addresses. Okay, so first is a and last is a broadcast IP address. There are 30 IP address can be usable, so total 32 IP address. Suppose if we are using the subnet 0. Okay, in the subnet 0, what happen, your IP address will be, or your starting IP address is 207.21.24.0/27 when you are using the /27. Okay, so now next subnet 1. So first from 0 to 31, so you are using almost 32 IP address in subnet 0. So next subnet start from 32. So 207.21.24.32. So here you are using the next IP or next subnet. So likewise you are going to make the IP address or subnetting up to 160. Okay, now again you can take any subnet from among all this. So you are going for subnet 6. Okay, so 207.21.24.192. So I am elaborated that subnet. Now what we are going to do, we are going to subnet of the subnet, subnetting of the subnet. So this subnet 6 is already subnetted. Okay, so again we are going to make the part of that, or small parts of that, 192 to 220. Okay, 192 to 223. Okay, so how exactly? So that is shown in the next diagram, you can see here. So again I am making the slash 30. Okay, so already take in the mind what I am explaining. You have already subnetted, then I am again going to subnet that 20 slash 27. Now that slash 27 I am going to subnet in a slash 30. So now you can tell me how many IP addresses can be used in single. So there are 4 IP address in a one subnet. Okay, so suppose subnet of 0. So starting is what? 207.21.24.192, that is the starting IP address, and the 32 means 30 means 2 raised to 2. Okay, so how many IP address remaining from 22 to 32 to? So only 2. So 2 raised to 2 means 4. So there are 4 IP address in a again another subnet. So it goes from 192 to 195. Okay, so 192, 193, 194 and 195. So those 4 IP addresses can be come in a subnet 0. So next subnet 1 start from 196 to 200. Again next subnet start from 200 to 203, then 204 to 207. Okay, so likewise you are subnetting the subnet. So these are all the part of this slash 27. So you can make such a subnets of all this subnet 0 to subnet 7. Okay, so that is called as a subnetting of subnet. Okay, so that is one example of VLSN. Okay, that is nothing but variable length. So this network has 7 slash 27 subnet with a 30 hosts, right? So you are using the 30 host each, and 8 30 subnets with a 2 host each. Okay, so actually there are 4 IP addresses, but first and last IP address we are not taking in a consideration because they are used for the broadcast purpose. So these 30 subnets can be used. So slash 30 subnets are very useful for a serial network. Okay, so when you are using the serial network from one router to another router, again from that router to another router or switch. Okay, so in the serial this 30 slash 30 subnets is very useful, where only 2 IP addresses are required. Now here is another example. Okay, so it has elaborated more. Same example that we have taken. So we have subnetted already, and this subnet 6 is again divided into again next subnets. Okay, so this slash 27 is divided again into the more parts. Okay, that is called as a subnetting of subnet. So here they have shown here. So how many IP addresses you can use? So in the 0, 207 20.21.24.192 slash 30. So that is nothing but what? This 207.21.24, that is nothing but what? That is your network ID. Okay, and this is nothing but your host. Okay, so 0 1 10. So how many hosts? There are 2 hosts. Which one? 193 and 194. Okay, so these are 2 hosts in 192. Why? Because 195 and 192 is not used, because they are used for the broadcast purpose. Now in next you can see here from 196. Okay, so 196 to 200. Okay, so next subnet is 196 to not 200, 199. So how many IP addresses can be used between them? 197 and 198. So what about 196 and 199? So they are used for the broadcast purpose. So I am again repeating that first and last, I am keep in mind, first and last IP address is used for the broadcast purpose. Only in between them IP address used for your you can use for your network. Okay, so likewise they have shown the IP addresses. So only for 30 there are only 2 IP addresses can be usable, right? So I hope you understand. So here I have shown the diagram how exactly this 30 IP address can be used. So here you can see 207.21.24.192 slash 30, right? So there are 2 IP addresses are usable, which are those 193 and 194 only. So here we can use 190. So here we can assign 193 and here we can assign the 194, right? So again here is again this is connected to here, so they are used the 204, so we are using here 203 and 205 here, okay, IP addresses. Now again this IP address is so this is again this is come from the another network, okay, this should be another network. Again this is connected here, so this router and this router, okay, this router and this router again connected by 196, okay. So 207.21.24.196. now you tell me which two IP addresses are usable here. 195, sorry, 197 and 198, absolutely right, okay. So 197 and 198, so 196 and 199 is used for the broadcast purpose. Only in between two IP addresses are usable. So one will come here, one will assign this router end and one assign this router end. So I hope you understand how exactly this slash 30 IP addresses can be assigned, okay. So this network has 7 subnet with a 30 host and 7/30 subnet with a 2 host, okay. So here if you go on into the routing, if you go into the practical, you can see here if you are going to configure the router, then you can see the routing table also. So in that routing table you will see directly this, okay. So 207.21.92, okay, in a C, that is serial 01 connected, serial 1, serial 2, okay, and this 204 is directly connected to fast ethernet, okay. If you go here, okay, so then you will understand here, okay. So this is nothing but the serials, okay, this is serial, this is serial, okay. Router ends are serials, okay. So again same they have shown in the for the next routing table, okay. So now we are going to final notes on VLSM. So whenever possible, it is best to group the contiguous router together, so they can be summarized, okay, aggregated by upstream routers. Even if not all the contiguous routers are together, routing table use the longest bit match width allows the router to choose the more specific route over a summarized route, okay. So you can keep subnetting as many times and deep as you want to go. You can go have a various size of subnet with the VLSM. Now discontiguous subnets, the two subnets from the same major network, that is 207.21.24.0, are separated by a different major network, that is 10.0.0.0, that creating the discontiguous subnets, okay. So you can see here, so here is the side A and side B. So this using the 24.32 and you are using also 207.21.24.0, okay. So they are look like a same, but they are using the contiguous network, okay. So you can see here, so 10.0.0.0./30, so this is a different network, this is a different network, and this is make again another different network that combine both the routers. So mixing the private addresses with globally unique addresses can create the discontiguous subnet. So that the main cause, however. So discontiguous subnets are a subnet from the some major network that are separated by a completely different major networks or subnet. So here question arises, if a classful routing protocol like RIP version 1 or IGRP is being used, what do the routing updates look like between site A router and site B router? So I will definitely answer this question. So here, so you can see, so two subnets again the same, so it be classful routing protocol and notably RIP version 1 and IGRP can't support discontiguous subnet because the subnet mask is not included the routing updates, right? Keep in mind that. So RIP version 1 and IGRP automatically summarize the classful boundaries. So site A and site B are all sending each other the classful address of 207.21.24.0/24, okay. A classless routing protocol RIP version 2 EIGRP OSPF would be needed, so to summarize the classful network address and to include the subnet mask in the routing updates. So here you can see the RIP version 2 and EIGRP automatically summarize on a classful boundaries when using RIP version 2 and EIGRP to disable automatic summarization on both the routers. So you can use the command router configure router, so no auto summary. So side B now receives 207.21.24.0 slash 27, and side B now receives 207.21.24.32.27. Okay, so you can see, so they are receive this IP address and this receive this IP network. You can say not IP address, you can say at a network. So here short-term solution IPv4 enhancement. So CIDR, the classless inter-domain routing that can be used, that we already discussed. So you can use RFC 100 and 5017, 5018 and 5090, 5020 standards. So VLSM, so variable length subnet mask can be used RFC 1009. The private addressing can be used RFC 1918. NAT and PAT, that is a network address translation, the port address translation. Okay, so they are not using anything. So we will see what is the private IP addresses that we have not discussed here. So we will discuss. So the private IP addresses, that is nothing but class A to B and C that can be used. You can use any IP address in between them. Okay, so the RFC 1918 internal address range is 10.0.0.0 to 10.255.255.255. For the class B, the range is 172 to 16.020 to 172.31.255.255 here in a table row number 2. And class C, you can use in between 192 to 168.020 to 192.168.255 to 255. So what is the meaning of this? So you can use any IP address in between them to your PC. That is called as a private IP addresses. Okay, so you can simply assign that IP addresses. So the private IP addresses can be used to address point-to-point serial link without using real IP addresses. Suppose if you want to perform the LAN connection between you and your friend's laptop, then you can simply use any IP address in between them. Okay, so here I have shown here. So you can see here they have used the site D and site C. So they are used the different IP addresses that are using the VLSM. Okay, so you can see 27, 30. Okay, the 27, so they slash 30. Okay, so they are nothing but the VLSM. So IP addressing and a non-public internet, a test lab, and the home network. So global addresses must be obtained from a provider or a registry at some expense. Okay, suppose if you want to take the internet, if you go to our college example, so you are using that IP address that we have paying to that BSNL or any service provider, whichever the service provider, we are paying them some money. That's why on the lease we are taking that IP address that is called as a static IP address, through we can access the internet. Okay, now okay, this already we have discussed. Now network address, that is a translation NAT. Okay, so we are using here source address 10.4.4.5, 10.4.1.1. Okay, so NAT is defined by RFC 16031 is the process of swapping one address from another in the IP packet header. Okay, that is what swapping one address for another in the IP address. In practice, NAT is used to allow the host that are privately addressed to the access the internet. Okay, so this is how they have explained here. The NAT translation can occur dynamically or statically. Okay, they can swap the IP addresses both dynamically, or you can statically. It can be done. The most powerful feature of NAT router is their capability to use the port address translation, which allows the multiple inside addresses to map to the some global addresses. Okay, so this is sometimes called many to one NAT. With the PAT or address overloading, literally hundred of private addresses nodes can access the internet using only one global address, and the NAT router keeps track of the different conversations by mapping TCP and UDP port numbers. Okay, the classless routing protocols. So these are few routing protocols that can be used while doing the classless routing. That is RIP version 1. Okay, that is a classful routing protocol. Okay, IGRP and BGP3. Okay, so these are nothing but the classful routing protocols, and these are nothing but the classless routing protocol. That is RIP version 2, AIGRP, OSPF, ISIS, and IGP4. So the true defining characteristic of classless routing protocol is the capability to carry subnet mask in their route advertisements. And one benefit of having the mask associated with each route is that the all zeros and all ones subnets are now available for use. So Cisco allows the all zeros and all ones subnet to be used with the classless routing protocol. So here are few classless routing protocols. So the true characteristic of classless routing protocol is the ability to carry the subnet mask in their route advertisement. So Jeff Doyle, routing TCP/IP, they have explained in this book. So what are the benefits? So all zeros and all ones subnets. So although some vendors like a Cisco can also handle this with the classful routing protocol. And what is the advantages of VLSM? So can have discontinuous subnets and the better IP addressing allocation. Okay, so there are very we can say very less IP addresses can be wastage. And now CIDR, more control over route summarization. Okay, so this is how the classless routing protocol benefits. So this is how we have done with this lecture. So in the next lecture we will start with the next module. So this is the last lecture of the module 3rd. So thank you very much.